Hello again. So today what I want to do is I want to talk to you about how to draw the circulations that we see asked so often in our SQA exams. Now this is not terribly difficult, and I have a method which I tend to use, which I will outline very briefly. If you consider that the ocean that we're talking about is a grid with land on this side and land on that side, then dead center is going to be the area of high pressure. The bottom part of our grid is going to be a low pressure, and the top part of our grid is going to be a low pressure. So this is just the navigable bits that we're interested in. And if you want to know more, then contact me and I'll give you a personal tutorial. Takes you about an hour on how to develop this. So this question in July 2020 asked for several things, but the key thing that I want to bring to your attention was that it said that we're only interested in this area from here to here, 20 south to 60 north. And so the reason I'm highlighting this for you is because anything outside these areas, the markers won't mark. Just like in the SQA exams, they tell you list 5 things. If you list 10 things, the marker counts the first 5 and rules the rest out. This is no different to that. So we're always going to start with the area of high pressure, and the high pressure dominates the ocean. There it is over there. You notice how large I'm drawing it. So this is my high pressure. Now, the wind circulation around a high pressure in the northern hemisphere is always going to be clockwise and outwards. So it's going to be like that. And I'm drawing it in because I want to show the examiner that I know what the wind circulation is. Now, what you've been taught is that you have these westerlies, and the westerlies are roughly going to be in this general area over here. So I'm going to put them in so that the examiner can see that these are the westerlies. We have, flowing this away, is we have the northeast trades. So the northeast trades are going to be flowing more or less like this. So there are my northeast trades. The other high that is of interest to us is this one over here, which is the high in the southern Atlantic. Now, most of this high, of course, is in this part of the world, so this is why I'm drawing it. Now, the wind circulation here is anti-clockwise and outwards. It's always outwards from a high, which means that we've got over here, blowing in that general direction, these southeast trades. So I'm showing the wind directions that you can see in the planetary circulation of winds model. You've also got variables which equate to these ones. So I'll put the variables in there like that, and I'll label them over here variables, also known as leakage winds. While I'm on the subject, you will notice that I'm using colors. Now, obviously, they don't want you to use red in the exam, but I'm using red. But you can use pink. It'll be similar. No one's going to penalize you if you use pink or orange. So there are our winds. Now, in the question upon which this drawing is based, there were 8 marks for the winds and the pressure systems. Now, I haven't finished with the pressure systems because I also need to put in the areas of low pressure. Now, this is the set in January, and in January, the ITCZ is going to be down here somewhere, roughly just south of the equator. And I'm going to draw the ITCZ like this as a zone, okay? And I'm going to label it ITCZ. There we go. So this is a low pressure. You've got another low pressure sitting over here, which is the Icelandic low as well. And the wind around the Icelandic low is going to flow like that. It's going to be anti-clockwise and inwards. There we go. So now the next thing is to draw in the ocean currents. Now the ocean currents will follow the wind circulations, which is why I drew the wind circulation like this. So I'll start here. Here is our canary current like that. Notice I'm using different colors so I can see the different things that I want to show the examiner. Up here, you've got the Florida current over there. I'll make this one slightly different arrow so it's easier to see. Up here, you've got the Gulf Stream, like that, and that goes into the North Atlantic current, which flows like that, and eventually it ends up over here as the Norway current. Notice that it's following the wind flow. So we've got over here also, following this one, we've got the the North Equatorial current. Down here, you've also got Antilles current over there as well. Here we're following this airflow now, and coming up Africa side, we've got the Benguela current over there. We've got the South Equatorial current flowing like that. And down here, we've got the Brazil current like that. Now these two, this one is working like that, and this one is working like that, and they're pushing a lot of water up into this landlocked area over here. And so you've got flowing backwards, you've got the countercurrent, sort of like that. There we go. So now we've got most of our current. There's another one over here you can put in also. There's the Labrador current over there. He asked for 10 currents, but we've got more than enough. Other things which were asked for in this paper was the ice limits. And in the North Atlantic at this time of year in January, ice is rarely found south of 40 degrees north and east of 40 degrees west. So there's my ice limit over there. As you can see, this gets very busy, but I will just call that ice. He also asks for area of persistent fog, and that's going to be here by the Grand Banks. And the reason why it's going to be here is because you've got this warm current flowing up like that, carrying warm air over it, and that warm air comes into contact with the cold Labrador current. So I will do this in a different color. I'll do it in this very light green over here. So I will call this the Grand Banks of Newfoundland, which is there in that sort of light green, and I'll call it fog, just so my examiner can see that I've got fog over there. The last thing that was asked for in this paper was the tropical revolving storms, which do not occur in the South Atlantic. However, if they did occur, then they would occur over there. And the reason they don't occur is because of the upper airflow. There's never been a recorded TRS in the South Atlantic. Nevertheless, there is my map, and this, incidentally, was worth a whole 32 marks. 32 marks is 16% of your paper. Now, as I've said before, if you can afford to throw these marks away, well, I'm very happy for you. Maybe you're an expert in everything else, and maybe you don't need all the other marks that are available to you. So there, for my 32 marks, is my weather map. If you're looking to be taught this, then I offer a very reasonable tutorial, and you can contact me at the website. Details are on the channel, and we take it from there. Hasta la vista. Keep smiling.